Welcome to the session. Greeting of the day. In today's class, we are going to talk about the hydraulic systems. In the previously, we have seen about this electrical control systems. We have three as mentioned: electrical control system, hydraulic control system, and pneumatic control system. It means actuating systems. As of now, we have seen about the electrical actuating systems of DC motors and those things. Now we are entering into the next topics of hydraulic system, where we are going to use the fluid for the pressurizing, for the movement. In general, we can tell we can able to operate a piston and the ram which pressurized here to move. So we have studied in the basic fluid mechanics subject the same formula we are going to utilize here. So it consists of the components. It consists of a movable piston connected to the output shaft in an enclosed cylinder. A movable piston, this one, a movable piston which is enclosed in a closed cylinder with respect to weight up and down, it moves. Now I am connecting this cylinder and the piston with respect to fluids. So this one, I'm talking about the parts what are the available here. So this mainly contains the cylinder and the piston, and this piston at two directions I want to operate, I want to actuate. When the fluid is in or out, the lifting of weight will occur. That is the output. Here the output is there. Here the output. How we are operating? When the liquid is controlled through B, it goes upward. When the same fluid is operated through A, it comes downward. So it moves down and weight will be comes down. So accordingly we should activate. What are the components now we have? So we have a storage tank. We have a fluid tank here. From here the reservoir. From here we want to take it down. And we have to reach here. So what happens? So the cylinders. So the cylinder storage tank and the filters. So the tank which we are filling the fluid may be having the dust particles. A fluid contains some impurities. Those impurities to be filtered here. After filtering, we have an electrical motor which is to pump this fluid to the connection of cylinder to operate. So the electrical motor and the pressure regulator. So this is what? Electrical regulator here, the pressure regulators, electrical motors with pumping actions, and pressure regulator to how much fluid flow we need. So the pressure regulators also have kept. In excess, if it is pumped, regulator regulates how much volume we need and it sends here. And we are going to send it here. But how much if it is excess, this excess volume of fluid will be returned to the excess, will see it is here. The excess will be returned back to the fluid tank, and it will be cyclic process as per the requirement will be given. As per the pump rotation, as per the regulator, the fluid comes out, and here we have the control valve. In which direction? Whether in the A direction to lift to be down, or otherwise in the B direction, whether lift to be in the upwards part. So accordingly, the control valve will work out. So what are the parts we have? The storage tank, filters, electric motors, pressure regulators, and the control valve. And the control valve, the leak-proof closed loop pipings are done there. So simple, I can able to write into the number format a cylinder with a piston, a storage tank, filters, electric motors, and then pressure regulators, control valves, and leak-proof closed loops piping. So 7 I have done here as a parts. So the working principle also similarly, the hydraulic system, this is how it will help. The output shaft transfers the motion or force. The storage of fluid tank, this is nothing but a fluid tank is a reservoir for the liquid used as a transmission media. So from the reservoir, it transfers the fluid from one end to the other end. It takes place from up and down action, that is actuating. The fluid is filtered to remove the dust particles, as I told you earlier. The fluid is filtered to remove the dust particles or any other unwanted particles and then pumped to the hydraulic pump. So from the filter, you see, filter filters the dust particles and impurities and it is pumped towards the pump through the pressure regulators. So that is what. The pressure regulator is used to avoid such circumstances which redirects the excess of fluid back to the storage tank. So what see, so number 1 I have written here as a fluid tank, and then now here I am talking about the filter, here I am talking about the pressure regulator. The cylinder movement is controlled by the control valve. So this next point is control valve. Which directs the fluid flow whether in the upward A direction or otherwise in the B direction. So those things. And the leak-proof piping is also important due to safety and environmental hazards and economical aspects also. We should take care to make a sealed one, otherwise the leakages will be there. If the leakages are there, the fluids which are available in the tank will leak out, the fluids which are available in the piston will leak out, and therefore the actuating systems will not work, or otherwise there will be error. So these things are to be enclosed with a leak-proof system. So this is also one of the very important content. So what are the applications here where we are using? We can able to use this in the industrial sectors, and then in the mobile hydraulics also we can able to use industrial sectors, mobile hydraulics. In automobile, mainly we are using the automobile parts, movement of on-off switches through the hydraulic systems we are using. Marine applications and the aerospace applications we are using. The other methods we can use instead of hydraulic, pneumatic systems also we can use. Hydraulic braking systems, pneumatic braking systems, so that those things are there to control. So the combined pumping and the driving motor unit is known as the hydraulic pump. It draws hydraulic fluid, mostly some cases of oil from the storage tank, and delivers it to rest of the hydraulic circuit. So it is pumped there, from there the rest of the all remaining parts is pushing. The speed of the pump is constant and the pump delivers an equal volume of oil in each revolutions. So for each motor rotations, the equal amount of fluid has been taken from the reservoir, from the tank, and it is supplied towards the all other parts. But how much it is needed, it is controlled by the pressure regulators, and in which direction it should go is controlled by the control valve. So those things are here, you see. So we have this pump, hydraulic pump is constant. Here we have the constant pumping action. But how much pressure we need? Pressure regulators it is controlled, and which direction we need, whether it is in the A direction or whether it is in the B direction, that this two we permit. After equal amount of pumping actions, this regulator will take the amount of 80% or 70% of the 100% of the pumping from the pump, and then the remaining 20% will be go back to this condition, and then this connection is connected again back to here. From the control valve also it is going to the reservoir back. So those things circuitry very important, and therefore now you see the hydraulic pumps are characterized by its flow rate. We are talking about pump. Characterized by the flow rate capacity, power consumptions, and drive speed and pressure delivered at the outlet. But we are told it is constant. And efficiency of the pump and the pump are not 100% efficient. It will not. It should give constant delivery, but it is not that much. The efficiency has been reduced due to its volume or density of the fluid, whatever it is which we are taking. Therefore, the efficiency also getting in reduction. So the efficiency of the pump can be specified by two ways. How I am categorizing the efficiency of the pump? Number one, by volumetric efficiency, and number two, how much power it is consumed, power efficiency. So which is in the ratio of actual volume of the fluid delivered to the maximum theoretical volume possible. By the calculation it differs practically. So the ratio between the theoretical output, the ratio and the practical output is the volume efficiency difference. So we are identifying the efficiency of the pump using the volumetric efficiency, number one. And number two, I am dividing in the power efficiency, how much it consumes, which is the ratio of output hydraulic power to the input mechanical or electrical power. The typical efficiency of pump varies from 90 to 80%. Right. So these are the understanding of how the general hydraulic system works. Let me understand a few hydraulic systems also. So few are centrifugal pump is there and reciprocating pumps are there in general. So number 1 and 2 we will see. The centrifugal pump. So the rotation of kinetic energy, it's delivered the fluid. The fluid with this small centrifugal, the term we know, when it is rotated, it throws outside. Centrifugal action, centrifugal force created at the centers and it's going to throw out. That idea we are going to use as a pump mechanism. So fluid enters the pump, impeller along or nearer to the rotating axis, it's at the center, and accelerates in the propeller and flung out to the periphery of a centrifugal force. Due to centrifugal force, it is going to rotate and it is thrown towards the outside. The delivery is not constant here because this turbine blades or rotations causes the movement of non-uniform flow which takes place here. Not suitable for high pressure applications. Here it is not constant. Then it is not is suitable for the high pressure application because we should hold with rotation and pressure applying the fluid. We should hold the weight. So high pressure application is not possible. The weight is any fluidic or centrifugal force changes, the lift will come down. The weight will come down because we can't able to hold at constant level. Therefore, high pressure applications and are generally used for low pressure applications only. So it is not suitable for high pressure, only generally useful for low pressure applications only. Maximum pressure capacity is 20 to 30 bars and the specific speed of 500 to 1000 rpm. So not self-priming, so that is all to be considered. Now I am coming to the second one. We have seen about one part of centrifugal pumping, which we are going to use in the pumping system. So pumping system is hydraulic system totally here. Hydraulic system is totally here. And I am saying about the various pumping mechanisms. What are the pumping mechanisms available and how we can able to use. So number one is a centrifugal pump that we have did, and one more thing of reciprocating pump. The reciprocating pump, a positive plunger pump. We are naming it as a positive plunger pump, also known as the positive displacement pump or the piston pump. Positive displacement pump or otherwise known as a piston pump. Often used where relatively small quantity is being handled and the delivered pressure is quite large. It is quite large. The crank is driven by an electric motor. Therefore, when the crank is rotating here, automatically it comes in and comes out. It is going to come inside. It is sucking. When the fluid tank from the tank here, when the crank is rotating by other means of electrical motor, this shaft is connected to the any DC motors. When it is rotated, it is going to come down as like our pistons. So when it is come down, it is going to suck in. When it goes upward, it goes out. So these outputs are connected to the regulators, and side by side connected to the control valves, and from the control valves we are connected to the piston in and out. So piston in and out we can able to connect. So these cases are very easy. So often used where the relatively small quantity is needed. The crank is driven by electric motors, and therefore the piston of the pump reciprocates due to The piston of pump reciprocates with respect to due to the crank rotation. Here there is no fluid leakages. We have completely sealed, and the inlet and exit are only maybe the leaking points. It means not leaking point, it is output and inlet points. So there is no fluid leakages here. Delivery is constant volume of fluid in each cycle. The amount which we are receiving inside and the amount which are moving outside are same. A constant volume of fluid is delivered in each cycle. So this is how. So the pressure regulators next. So out of the hydraulic entire system, we have seen about the various content of various parts of tank, pump, regulator, control valve and the cylinder. So that the tank is simple storage, and then we have seen the pump, centrifugal pump and the reciprocating pump. The pump lift. The pump creates a negative pressure at the inlet which causes the fluid to push up in the inlet pipe. The maximum pump lift is given by the pressure head, and the cavitation is the formation of the vapor cavities, and therefore the pump lift should be as small as possible to decrease the cavitation and increase the efficiency of the pump. So here we have to check the pump lift. So next one, we are generally in the physical diagram we have seen about the pressure regulators. So that one we have to elaborate here, the pressure regulating systems. After the pump, from the reservoirs, after the pump, we have the pressure regulators here with respect to valves. Maybe a control valves, maybe in which direction, how much pressure we needed. So the pressure control valves are here. Output, the output, how much it should deliver and how much it is to be, how much it is excess, which is to be sent to the reservoirs. The process of reduction and the high source of pressure to the lower working area, suitable for those applications. An attempt to maintain the outlet pressure, within acceptable limits, performed by using a pressure regulators, match the fluid flow with the demand. At the same time, what happens there? A regulator must maintain the outlet pressure also within the acceptable limits. The limit should not exceed. The limit is exceed. After the pressure regulator, we are going to do the control valves. From the control valve, we are going to go inside only. Therefore, it is not permissible to give the excess pressure. This excess pressure to be monitored and it should be regulated in which direction we should go, whether in here or otherwise in the how much pressure to be maintained very well. So advantage of hydraulic systems. So the hydraulic systems uses incompressible fluid which results in the higher efficiency, and therefore it delivers constant power output which is difficult in the pneumatic system. Hydraulic is preferable than that of the pneumatic system. Here we are getting the constant outputs. Possibility of leakage is less. When the leak group is given, possibilities become reduction. Hydraulic systems are compared to that in the pneumatic systems. These systems are performed well in the hot environment also and the different conditions. But what is the disadvantage here? We have very few. Methods of storage tanking. Large storage tank is needed to fill or maintain these fluid tanks, and the piping, cylindrical and pistons are involved, which may corrode also, which may get the corrosion due to its involvement with respect to fluids. Therefore, the structural weight may be differ with respect to sizes. When the size and weight changes, the fluid pressure applied will change with respect to the regulators applied there. So the hydraulic fluids, if not disposed properly, can be harmful to the environment. So that is how we should maintain such things to accommodate. So the summary. In the actuating systems, in this class we have seen about the hydraulic systems. On that hydraulic system we have seen the various parts such as tank, and then the pump, control valve, and the cylinder with piston to operate. And the pump we have classified into two categories of centrifugal pump and reciprocating pump. The remaining part of the subject we'll see you in the next session. Thank you.